Good morning. I'm John Henry for Frain Industries, and we're here with a Tronics front and back labeler from their rental fleet. And we're going to walk you through how a pressure-sensitive labeler works, the various components, and how we get from an unlabeled can to a labeled oil can. So the first thing to do is get the bottles onto the conveyor. This is usually from an upstream machine. In the case of an F-style bottle, they all need to be oriented the same way. And we're going to turn on the conveyor. And the first thing that we have to do is make sure that we get the bottles adequately separated so that the labels don't overlap, so that there is a space between the bottles as they go through the labeling process. Now, the maximum space usually is not important in this particular instance. The minimum space is. We'll want 1 inch or 2 between each bottle. So we use a spacer wheel to achieve that. On other systems, we might use a timing screw or another mechanism to get the spacing. And the spacer wheel is just a wheel that's going to rub up against the bottles. And I turn it on. And you can see how it holds the bottles back and provides the separation. The bottles come through the spacer wheel, and on this particular machine, the next step is the aligning chain. The aligning chain is not strictly necessary on this machine because this is usually used on an oval bottle or an odd-shaped bottle to get it perfectly straight and aligned as it goes through the machine. On an oval bottle, if it's twisted slightly, the labels will go on the bottle, but they will be in the wrong position. One label will be too far to the front of the bottle, the other label will be too far to the back of the bottle. So we use the aligning chains. If this was a dedicated machine for this type of bottle, these aligning chains probably would not be here. These are used mainly for oval and other hard to orient bottles. After the bottles come through the aligning chain, they're captured by a top hold-down belt. This belt is going to be moving at the same speed as the product conveyor, and the purpose of this belt is to keep the bottle straight and keep the bottle from getting pushed out of position by the labeling head as the label gets applied. It's important that the top hold-down belt run at exactly the same speed as the product conveyor. And here you can see the bottle coming through past the labeling heads, discharging at the end of the conveyor. I have raised the top hold-down belt for purposes of illustration. As the bottle exits the timing chain, it's going to pass the photo eye. The photo eye is going to see the leading edge of the bottle is going to start a timer, and as the bottle travels on to the labeling head, to the peeler plate, the timer is timing so that when the bottle is in the correct position relative to the peeler plate, the label starts dispensing. The label will be dispensed out onto the bottle. These brushes will wipe the labels down, and the bottle will continue to the discharge. On this machine, because it's designed to be as generic as possible, there's also a wrap station and a backing plate. This would be for a round bottle. It's not used on this particular S-style oil bottle. So now I've turned the labeling heads on, I've turned the conveyor, the aligning chain, the top hold down on. We're going to run a bottle through and actually put a label on the bottle. So here comes the bottle through the aligning chain, picked up by the overhead conveyor, top hold down, and as it passes the labeling head, a label is dispensed and applied to the bottle. So you can see that this label is slightly out of position. It's pretty well straight, but it's a little bit to the back. Now this could be because of bottle handling, or it could be because of a label dispensing issue. If the label head is dispensing erratically, you can get this. So it's an easy thing to determine where the problem is: labeling head, bottle handling, timing. We're going to take this bottle and we're going to run it through again. And we put a second label on, and you can see the second label, but it's pretty close. So this tells me that it's a timing issue. Not an issue with the labeling head being erratic, not a problem with the bottle itself being out of position. So it's easy to fix just by adjusting the timing. On this, I have adjusted the label application position, or the timing delay from the photo eye, and you can see this was the original label. This was the next label that I put on after the first adjustment. I adjusted it a bit more, and I adjusted it a bit too much. So I'm going to go back, I'm going to take a little bit of timing out of it, and we'll move the label back this way a tad, and we should be having it perfectly centered. Now looking at the top label, you can see that I have moved it back about 1/16 of an inch, and it now looks like it's pretty well centered in the bottle. Now you notice that I'm not using fresh bottles. I'm putting the labels one on top of the other, because if I used a fresh bottle, it might be hard to see how much I've moved it. So this gives me an indication of the movement. So now let's try a fresh bottle and see if the label looks like it's in position. So now you see a fresh bottle, fresh label, and the label looks pretty well centered. We should probably have a label gauge to determine if it's exactly centered, but to the eye, it looks pretty good. On this machine, the label position is controlled electronically, and there's a digital readout. There's an up and down button that allows you to adjust the time delay, which is what controls the label position. The other factor controlling label position is the position of the photo eye. If the photo eye is moved, the label position will move, because the labeler is timing based on the time between when the photo eye sees the bottle, a delay, and when the label is dispensed. If this photo eye is moved, even though the digital indicator says that we're in the correct timing, the label position will not be correct. These photo eyes should always be permanently fixed. Do not use hand levers, do not use hand knobs, because if you do, they will be adjusted, and then the electronic adjustment will be out of calibration. It will take more time to set up. We currently have the labeler set up with a conveyor speed of 11.4. If we want to increase the speed, on some older labelers, if you increase the conveyor speed, you have to increase the speed of everything else. You have to manually adjust either the position of the photo eye or the timing of the label dispensing. This machine has a PLC and servo motors where everything is feeding back, so everything stays synchronized regardless of what you change with the conveyor speed or machine speed. So I'm going to increase the machine speed fairly dramatically. This is very nice with the digital readouts, so you can always get back to exactly the same point regardless of who's setting up the machine. We've increased the speed from 11.4 to 14. We're going to run the bottle through, and if everything stayed synchronized, the next label should be directly on top of the previous labels. And as you can see, the labels are directly on top of each other. So we did increase everything perfectly. Nothing changed. This is why modern machines are better. They have this capability. Some of the older machines, you really can take a lot of time when you change the speed, having to make multiple adjustments. This is the front labeling head, and it's a pretty standard pressure sensitive labeling head. Doesn't matter who you buy it from. Pretty much what the specifications are. They're all going to be basically the same. And we start off with an unwind roll. This is the label roll. It sits on a plate, and this plate has a brake on it, so you can see it's a little bit hard to turn right now. But when we pull the labels forward, we're going to pull this arm to the front, release the brake. Now this spins freely. It's very important that this brake be in place and properly adjusted so that you maintain a consistent tension on the label web. Consistency of the tension is what's going to give you consistency of the stop position. You have a range of how much or how little tension you have, but the really key factor is that it be consistent. One of the problems I've run across in the past is the label core slipping on this shaft, so that even though the brake is working correctly and this plate is locked, the core itself will spin, causing you problems with the tension. So there's a couple ways to get around that. One is to take a label or two, put it inside the core to give it a little less inside diameter, a little bit tighter fit. A better way is to use an unwind axle that has a gripping mechanism to positively grip the core. As this machine does, you can see that core is not going to slip on the shaft. So we come out over a dancer roll, over a guide roll, over the brake, tension control, over another guide roll. There's a brush which provides a little bit of tension. This brush here is normally at the discharge or as the label is being applied to wipe the label down. We've moved it out of the way so you can see what we're looking at. The label web comes through, and here we have a capacitance sensor. Now most labelers are going to use a photo eye rather than a capacitance sensor. If you're using a clear label or a thin film label, you will need a capacitance sensor rather than a photo eye. Because this is a rental machine, it's built to be as universal as possible, so it comes with a capacitance sensor which works on either an opaque label or a clear label. The label feeds down to the peeler plate, and you can see the profile of the peeler plate. Some people will call that a knife edge. As the label feeds across the peeler plate, it's going to want to keep going forward while the web is pulled to the back. And I'm manually simulating it here. And this is an issue. I've now created some slack in the web, which is going to cause a problem later on. You notice that the label has drooped out of position, and We need to fix this before we snap the web and break it. So I'm going to remove that label manually. I'm going to pull the web back and retension everything. I'm going to trigger the photo eye manually, so if you watch what's happening at the label, well, that label would have been out of position because first it had to advance to take up that blank space, but this labeler is smart enough to know that there's a blank space and then re-register so that it stops in the correct position. The label itself goes forward. The web comes around to the back. It goes into a nip roller. The nip roller is a rubber roller with a tension roller, which can be opened so that you can rethread the labels. This is driven by a servo motor, and this turns on, pulls the label web forward until the capacitance sensor sees the gap between labels, and then turns off, stopping the label in the correct position. So this nip roller is what's actually controlling the application and the stop position for the next label. The nip roller itself, servo-driven, controlled by the machine PLC. The web, the backing web, comes out and is taken up on a take-up roller, which doesn't need any particular tension, just needs to accumulate the film or the backing web so that you can get rid of it. If this nip roller is open, or if somebody has sprayed it with WD-40, or if it's badly worn, it can slip. And what will happen when this slips is that the label will no longer stop in the correct position. It may slip enough to where the label doesn't dispense at all. Now on this labeler, on this setup, you can see that the label is extended past the edge of the peeler plate by about 1/16 of an inch, and different machines, different setups will require different extensions. This machine, the extension is set up electronically from the control panel. On some machines, it'll be set up by moving the photo eye or capacitance sensor forward or back. Once the position for this has been determined, it should be locked in place. Use Allen screws rather than hand levers or hand knobs, because if an operator can adjust this, they will. So you want to avoid adjustment so that the digital settings will always be correct. Now I'm going to increase the digital setting so you can see the effect at the control panel. Right now we're set on 3. I'm going to extend it quite a bit just for illustration. I've extended the label flag to 12. And here you can see it's now extended out about 3/8 of an inch. I can set it back to 0, and now it should stop flush with the edge of the peeler plate. And it did. On the chain aligners, we have 2 adjustments. We have one adjustment for height. We have another adjustment for in and out. You want the chain aligner to catch the bottle more or less at the center of gravity so that it doesn't tend to tip over as it goes through the aligner. You also want the 2 chain aligners set so that the bottle is centered on the conveyor. So your first setting would be the chain aligners. The bottles will then come into the top hold down belt. The only adjustment here is the height, which is around the back. And this has a locking pin, which is very nice to prevent the adjustment from vibrating out of position, and then a crank that turns the screw to raise and lower it. The supports are very rigid so that the belt itself always stays parallel to the main conveyor. Once the bottle is centered on the conveyor, centered by the chain aligner, centered under the top hold down belt, you'll need to adjust the position of the labeling head. There are a couple of adjustments that you're normally going to have to worry about. One is the height. This wheel here raises and lowers the labeling head to center the bottle vertically, center the label vertically on the bottle. A second wheel underneath moves the labeling head out and in, because you want the peeler plate to be as close as possible to the bottle. You don't want to touch the bottle, but you want it as close as possible to the bottle so that the label goes on smoothly. Now, if you adjust the in and out dimension, you may adjust the position of the label on the bottle. It's going to depend on the particular labeling machine and the particular bottle. So you may have to go back and adjust your forward and back position electronically once you do this. You also have a skew adjustment. And if you're getting labels that are skewed, they're not straight up and down oriented to the container, this is the problem. The labeling head needs to be perfectly level with the bottle. So this, I'm not going to make the adjustment, but by loosening this, you can adjust the tilt angle of the peeler plate. We have another adjustment here which allows you to adjust the labeling head this way. Normally the labeling head should be perfectly parallel to the conveyor. The conveyor should be perfectly level, the labeling head should be perfectly level in the lengthwise dimension. But occasionally you may want to put on a label that's skewed, or you may need to correct a skew in a label. This is the adjustment that you would use to correct that. The labeling head should also be perfectly horizontal relative to the conveyor, and if it's not, the peeler plate will be closer to the top of the bottle than the bottom, or vice versa. In the case of a tapered bottle, you will want it to be angled so that it's at the same angle as the bottle taper, and this is the adjustment for that. Now you notice that all of these have scales on them, so you have a numerical setting that you can set to. So scales there, scales here, and once you get the labeler set up for a particular container and label combination, you should write down all these numbers and keep them somewhere safe, because once you know those numbers, it becomes much easier to set up the labeler, even if multiple people are doing the setup, because they can just adjust the various parameters to a specific number rather than having to do it by guess. We have a brush here which I've moved out of the way so you can see the peeler plate and the label dispensing. But this brush would normally be located in a position like that. So as the label is dispensed onto the bottle, this brush actually wipes it down. And this is a fairly soft brush. You may have some bottles where you need a really stiff brush or even something like a rubber squeegee to wipe the label down. I did a project once with a milk bottle where it was a straight side, but once it was full of milk, it bulged out a little bit, and we solved that problem by using a really stiff rubber squeegee that force the bottle back straight as we were applying the label. This machine also has a wrap belt on it. If you were doing a round bottle, it would look much the same. You would raise the top hold down belt out of position. You would use only one labeling head normally. The bottle would come through, it would get the label, the front 1/4 inch, 3/8 of an inch, 1 inch of the label applied to the bottle as it passes the labeling head. It will come into the wrap station, and this is just a foam rubber belt that's going to be rotating in this direction. There's a backing plate, which is also foam rubber to absorb any ovality in the bottle. And this is just going to spin the bottle around as it goes through the wrap station and wrap the label around the bottle. If you have the top hold down belt lowered down in place when you're doing this, what can happen is, what will happen is the bottle will want to tilt. It may also unscrew the cap. So you would not normally use the top hold down on a round bottle. This is a rental machine. It's built to be as universal as possible for as many different products as possible with no modification. The back side of the machine is essentially the same as the front of the machine. The only difference between the labeling heads is that they're a mirror image of each other. Here you see the adjustment in and out for the backing plate. Now notice how solidly this is built, because you need to make sure that you keep it parallel to the bottle. Now you notice on this machine there's an emergency stop on the back side. This is a very important feature. I don't think you can have too many emergency stops, because when something happens you want to be able to shut the machine right away. And the machine will stay stopped until the emergency stop is reset, which requires turning and it will pop out. And on the front panel of the machine is another emergency stop, and you can see all power has been killed. That was not depressed, so it's still out. I have to press the start button, and then I have to restart the machine components to get the machine started again. On this machine, you may be okay with just one emergency stop, but on a longer machine, you might want an emergency stop at that end, also an emergency stop at the infeed end on the back side. You have one at the control panel. If the machine was longer, you might want a fourth emergency stop at the discharge on this side, because if this is in a packaging line, to get to the back you may have to walk around quite a bit. This label roll is 12 inches in diameter when it's complete. This label plate will hold up to a 12-inch diameter roll. If you're running high speeds and long runs, a 12-inch roll may not give you enough labels, especially if the label is long. And you may want to go to a larger roll size. The maximum you can handle here is 12 inches, because if it gets any larger, it's going to have some interferences. If you go to a 16 or even a 20-inch roll, you've got some other issues you have to be aware of. On this roll, we're just pulling the labels off the roll. On a larger roll size, we're going to have a motorized or a powered unwind. And that means we're going to have a sensor to tell us when we've got slack in the web and when we need more labels. That will turn the motor on, unwind some label stock, and then turn off. So if you do need a larger roll size, it is going to require a motorized or a powered unwind. I've changed the speed on the overhead conveyor. It's running at about 70% of the speed of the main conveyor. And what we're going to see is that the label is going to be out of position, the bottle is going to slip on the conveyor, and the bottle is going to tip over. It's not going to tip over in the hold down belt because of the square top of the bottle, but it will tip over as it exits. So, here we go. And you can notice that it's running more slowly and slipping on the bottom conveyor. The label dispensed because it thinks the bottle's already there. As it exits, it falls over. So I have now turned up the speed of the overhead belt conveyor to about 130% of the lower conveyor, main conveyor. We're going to run the bottle through. Once again, you can see it slipping now forward on the main conveyor, and the label finally dispenses way after the bottle has passed. We now have the labeling head set up about twice the normal speed. As the label comes out, you can see that it's actually trying to push onto the bottle and does not lay down. What we are actually getting as the label dispenses is an effect like this, but because the back edge isn't laying down because of the stiffness of the label, we're not getting this bubble that we would with a thinner or a longer label. This is strictly due to the labeling head dispensing the label faster than the conveyor. The linear speed of the conveyor, labeling head, and overhead conveyor all must match exactly. I have now slowed the labeling head down to about 50% of the speed of the conveyors, and you're going to see what happens when the head runs too slow relative to the conveyors and top hold down. Because the bottle is trying to pull the label out of the head, but because it's not really sticking to the bottle, the label just slides on the bottle and winds up flagging off like this. This F-style bottle would normally be full of oil and would have a cap on it, and it's probably going to be heavy enough, especially if you're running at slow speeds, around 50-60 bottles a minute. You really don't need the top hold down. If you don't have the top hold down, the speed of the label dispensing becomes even more critical. As we will see just now, we're going to run through. The labeler is still set at about 50% of conveyor speed. This bottle is empty and lightweight, so we just pulled the bottle out of position with the label. If the bottle had been full, it might be heavy enough, there might be enough friction on the conveyor to where we would actually pull the label off of the web, which would mean we'd create slack in the web. It would then snap back and could break the web, which would stop the labeler. You'd have to shut down, you'd have to rethread your label web.